Hi, everybody. Right now, we're going to go over a solution to the Applying Homeostasis to Clinical Reasoning worksheet that we did in class together. So here's a solution that you can watch on your own time. So we want to consider the following scenario. Miriam has caught a stomach flu that is going around campus and has been vomiting for the past 24 hours. Not only has she been unable to keep fluids down or food, but she has also lost the acidic digestive juices secreted by the stomach that are normally reabsorbed back into the blood farther down the digestive tract. So the first thing we need to figure out, in what ways might this condition threaten to disrupt homeostasis in Miriam's internal environment? So if you look down at the tips I mentioned here, what we want to do is think of the factors that are homeostatically regulated. Okay, so these are things like nutrients, oxygen, CO2, water. I can go on and on. And so this paragraph up here actually gives you some clues. So it does say fluids. So she's having a hard time keeping down fluids, plus she's vomiting them up. So she's probably becoming dehydrated and therefore not keeping water in. So we're going to have to deal with water. The second thing is food. So she isn't maintaining nutrients. Okay, and then the third thing is it mentions digestive juices. Okay, acidic digestive juices. So if she's throwing up acidic juices and she's not reabsorbing them back into the blood, that's a clue to you that we must need to reabsorb those acidic juices. So that is probably throwing off her pH. So three things: we said water, we said nutrients, and now pH. Those are three homeostatically controlled mechanisms that are off in her internal environment right now. Okay. So when you're sick, your body now then is going to want to replace those things or control it somehow homeostatically. Okay, so that's our next question. Pick two factors we mentioned and describe how her body will bring them back into homeostasis. So let's start with water. With water, she doesn't want to lose that, so the body's going to kick into gear right away and try to maintain the water that she has in her body already. Okay, and so one of the things she'll do that is through her kidney, right? So we urinate and there's water in there, so the kidney will start to reabsorb water and not send it out through the urine. So the kidney's able to do that. So even if you're not sure of the functioning of the kidney, what we're really looking for is that negative feedback control. So she's losing water. We want to maintain water or increase water. So one way to at least maintain and not lose any more is the kidney will stop releasing water. So that's a reversal of the normal of the situation she's in right now, right? Negative feedback. It's a reversal of what's happening now. Other things students mentioned in class is that she might then start to feel thirsty, right? That's a behavioral drive, and that is definitely a way homeostasis can get us back into increasing our water levels. So the hypothalamus is the integrator, is sensing, right, that we have low water levels, and so it will then cause your mouth to, the membranes to dry up, make you feel thirsty. So then that's a behavioral drive to go drink water. So again, the key here is negative feedback. We're having low water, and so the body is reacting in a way to increase water or at least not lose any more water. Okay. Second one, nutrients. So it says she's throwing up, and she's throwing up nutrients. So maybe one example at this point we can use is something like glucose. You learned in general biology that the liver stores glucose in the form of glycogen, right? And so what our body can do by a negative feedback control, it can signal the liver, right? The integrator, the hypothalamus, will signal the liver to start breaking down glycogen and release that glucose into the blood. So negative feedback. We had low glucose, we're going to increase glucose. Okay? The third one, pH. So pH is also homeostatically controlled in the blood. This one might be a little bit more complex, so maybe you don't choose this one to determine how it's homeostatically regulated. But some of you in class were right. Some of you figured out that we can control our blood pH by our respiratory system. Okay, and we'll learn exactly how we do that. But so we might adjust at this level, it's okay to say we might adjust our respiratory system, our breathing, in order to not allow our blood to become too basic, which may be what's happening if we're losing those digestive juices. Okay? The kidney can also maintain hydrogen ions rather than secreting them out through the urine. That would also help to increase or decrease, our pH to make it more acidic. Remember, when you decrease pH, you make it more acidic. Okay, so those are 3 homeostatically controlled systems, and that's how we would answer this question.